Hello, everyone. This is Samuel Akumbom Tomwen. This assignment is part fulfillment for my master's program uh, in the College of Science, Engineering, and Technology at Grand Canyon University. The title of the course is UNV 5250501 Technology Implementation of Security Solutions. The instructor's name is Oladipupo Sam Adeyemi. Today is the 8th of May 2024. My date shows 7 May because I started doing the assignment yesterday. So let's get into it. Many organizations are increasingly moving toward cloud computing, and this requires cybersecurity professionals to be familiar with the effects cloud computing has on security. This paper will look into some of the fundamentals of cloud computing and related security issues. As Microsoft put it, simply put, cloud computing is the delivery of computing services, including servers, storage, databases, networking, software, analytics, and intelligence over the internet or the cloud to offer faster innovation, flexible resources, and economics of scale. To achieve this, different vendors have come up with different virtualization platforms. Virtualization, virtualization platform is a technology that can be used to create virtual representations of servers, storage networks, and other physical machines. This from Amazon in 2024. There are several vendors that have different virtualization platforms in the market, such as VMware ESXi, Oracle VirtualBox, Citrix, and VMware vSphere. These platforms grouped together can be broken down into two categories called hypervisors. So there are actually two types of hypervisors. Let's look at the next slide. The first type of hypervisor we'll look at is called type 1 hypervisor, which is a type of hypervisor, or it's a virtualization platform that interacts directly with the underlying hardware of its host, the device on which it's installed. So an example of type 1 hypervisor is a VMware ESXi. A type 2 hypervisor, on the other hand, is also called a hosted hypervisor, which is a virtualization platform that interacts with the underlying host machine hardware through the host machine's operating system. So it uses the host machine's maybe RAM, storage, but it does not access it directly. It has to go through its operating system. An example of this is the VirtualBox Oracle. So there are different cloud services such as software as a service, platform as a service, or infrastructure as a service. So let's look at software as a service. Software as a service is a software distribution model in which a cloud provider hosts applications and makes them available to end users over the internet. An example of a software as a service is a Dropbox. The next service to look at is platform as a service. So platform as a service is a cloud environment that includes everything developers need to build, run, and manage applications from servers and operating systems to all the networking, storage, middleware, tools, and more. An example of a platform as a service is Microsoft Azure. So think of platform as a service just like a foundation where developers can build applications. And then there's infrastructure as a service. Infrastructure as a service is a form of cloud computing that provides on-demand access to computing resources or infrastructure such as servers, storage, networking, and virtualization. A perfect example of this one is the AWS EC2 instance. So in this case, users do not own the EC2 instances. They only get what they pay for, and AWS provide these resources on demand to the users. So let's look at service-oriented architecture. Still, Amazon in 2024 describes service-oriented architecture as a method of software development that uses software components or services to create business applications. This method is used by developers to reuse services in different systems or combine several independent services to perform complex tasks. For example, many organizations use the authentication functionality in their business processes. Instead of rewriting its authentication code for all business processes, developers can create a single authentication service and reuse it for all applications. Our next slide talks about deployment methods. So in this paper, we talk about three deployment methods. We talk about the private, we talk about the four. We talk about the private, we talk about the public, we talk about the community, and we talk about the hybrid. So the private, first of all, cloud deployment model functions as a virtualized computing platform and has a deployment architecture which varies depending on the amount of data a user wants to store or who has access to that infrastructure. Private cloud. The private cloud deployment model is a one-on-one environment for a private user. So a private user here could be a private organization. The user or organization does not share the infrastructure with anyone else. It has advantages such as better control since it is not shared with other organizations, data security and privacy, supports legacy systems, and it is easy to customize since it's used by a single user. On the other hand, it has drawbacks such as less scalability since they are scaled within a certain range because there are less amount of clients. It is also more costly. So the second deployment model is the public cloud. So public cloud is actually the opposite of the private cloud, the exact opposite of private cloud. In this model, anyone can access the systems and services so long as they have the rights of creation and access privilege. The infrastructure in this model is controlled by the vendor that delivers the services and not the user or organization. Because it can be accessed by many users, it is less secure. That's a disadvantage. For the same reason, it is not easily customized since there are many users. Another disadvantage. But then it has a few advantages, such as it is less costly. So let's look at the community cloud deployment model. So this model allows systems and services to be accessed by a group of organizations. In this model, the services of different cloud deployment models are integrated to address the specific need of a community, industry, or organization. This model is very cost effective as different communities, organizations with similar interests can use the same model at a time. It also provides better security. Resources are shared when this model is employed. Limited scalability is one of its biggest drawbacks, since many organizations share the same resources according to their collaborative interests. It is also rigid in customization. And then we have the hybrid cloud. The hybrid cloud deployment brings about the best of both worlds in the private and the public cloud deployment method by bridging them with a layer of proprietary software. This method brings about the advantages of flexibility and control, cost reduction, and added security. However, it can be difficult to manage and users can experience slow data transmission. We cannot talk about cloud deployment without talking about security, some storage, and some legalities. So let's look at those security concerns. It is true that cloud computing brings several advantages to organizations, including better performances and lower costs, but there are some security challenges that can come with them too. These challenges include insufficient cloud security expertise and skill set, identity and access management, cloud compliance, and misconfiguration. There is also the concern for data security and privacy. This is very important, the privacy. Privacy issues that comes about when a public third party controls data storage. Now, this is in the case of maybe a public cloud deployment or a hybrid cloud deployment. For example, in a public cloud deployment scenario, an organization can opt to use third parties such as Kaseya, which is a storage vendor, to manage their data storage. While these organizations, like Kaseya, are required to meet certain compliances, users or organizations can never be 100% sure since the management of the data is out of their hands. To counter these security concerns, we can employ processes such as the DevSecOps that can be used in mitigating certain access control risks by improving the quality of encryption and counter vulnerabilities. Intrusion detection prevention tools can also be put in place by vendors. And this brings us to the last slide, which is our references. Thank you for watching. Have a wonderful evening.